All right, so yesterday we had a little quiz where you were asked to evaluate this simple little series parallel circuit. And most of you found this, I think, rather easy. You finished it quickly. Some of you didn't. That's okay. So we'll talk about it. And where I could see a lot of you kind of messed up was not understanding what was parallel and what was not. So if we follow this around, remember, series is how many paths? One path. So far off we have one path, right? One path through there. But when we get to this point right here, how many ways can we go?
Two.
That is the beginning of the parallel circuit. So this one and this one are in parallel. Yeah?
Yeah.
So another way to draw that would have been to be like this. And then it goes this way and this way. Because the current is going to split here. Some of the current's going to go that way and some of it's going to go that way. Follow so far?
Yes.
All right, so it's going to come around this way and come around this way, and they're going to join back up here. And now it's going to go this way. So that is the same thing as going this way. So there's only one path through this. Or we could have done it the other way around and said, well, wait a minute, what if we start from the other way? Well, fine. The 10 ohm is in series, right?
Mm-hmm.
And then we get to this point, and we're back to parallel. So one way and two ways. And then it meets back up here. And so the 25 ohm and the 10 ohm are in series. And the 50 and the 75 are in parallel. So looking at that, I have to combine these two right here, right? And so we'll make that into one, EIR. Or if you like, we can redraw that. So we had a battery that went through a resistor here, which was 25 ohms. We'll call this R1, and it was EIR. And this one can be R2 and 3. 2 and 3 combined. And then it goes back into R4. Everybody's with me so far? All right. So R1 was 25 ohms, 25. Oh, there's EIR here, EIR. What was given here? 12 volts. 12 volts, that was all that was given. 25. This one down here was 10. 10 ohms, that's 10 ohms. And R3 is...
R2 is 50.
Yep, R2. R2 is 50. And R3 is 75 ohms. Yes.
Could we have combined R1 and R4 and made it a parallel circuit?
How would you make a parallel to that? How many paths are there through this one?
One.
How many paths are through this one?
One.
These are not in parallel with each other.
Okay. Got it.
That'd be like taking a series circuit where we got rid of all this right here and go, well, let's just combine them into parallel. How do you do that? Because they're clearly in series. So,
Okay.
nope. Where the heck was I? There we go. Okay. So if R2 is 50 and R3 is 75 and they're in parallel, and I combine them into one, then it is
30 ohms.
30 ohms. Trust you now. 50, x minus 1 plus 75, x minus 1 equals, x minus 1 equals 30. All right. 30 ohms. Now what are we looking at?
Series.
Simple series circuit. So we can solve that pretty easy. Our total is
65
0.65 ohms. Therefore, current flow is 0.185 amps or 185 milliamps. We'll leave it there, 185. So this has to be 185 as well. This is 0.185 as well. This is 0.185 as well. All right, everybody knows where I got all those numbers from? Okay, finish it off. We have resistance up here. Voltage drop.
4.625.
It's 25 volts. Voltage drop here.
5.55.
5.55 volts and
1.85.
1.85 volts. All right, so 1.85 plus 4.625 plus 5.55 should equal about 12.
Yep.
All right, so what we need is this information right here. I wonder if I can do this. No, don't do that. That was the wrong thing. No, won't do it. All right. You remember what it was offhand? 5.55?
5.5. Yeah, for the parallel.
Yep.
0.85.
0.185 amps, and resistance was 30? 30 ohms. Okay, so this right here is the total of R2 and 3, right? That is the total of 2 and 3. Everybody's with me so far?
Yeah.
Right. We got to split it back out because we don't know. Coming up to this point right here, we have 0.185 amps. Some of it's going to go this way and some of it's going to go that way. We do not know how much. We also know that we have 5.55 volts across both of them, but they're in parallel, so that tells me that
Like the same.
it's the same. 5.55 volts, 5.55 volts. Now, yesterday I used a term that this kind of becomes the battery for it, if you will. And if I was going to redraw that, then it would look something like this. Where this information, 5.55, 185, and 30, just becomes the total for going into R2 and R3. Follow? All right, so it's all you're doing is doing that. So this becomes 5.55. This is 5.55. We already know that this is 50, and we already know that this is 75. So all we got to do is Ohm's law to figure out what the current flow is, and it's like 0.111, I think on one.
Yeah,
Right.
0.111.
0.111 and 0.074 amps. So there we go. And we already had the information over here, which we filled out on another page. 4.625 volts, 0.185, 0.185, and 1.85 volts amps. So we're looking at it, and we're saying, okay, we've got 5.55 volts across this, basically, across that, between there and there, which makes sense. We had a voltage drop here and a voltage drop here. So that took away some of our voltage, so what's left is 5.55 volts. And it's going to share that across both of them. They both get 5.55. Then we had 1.85 amps hit this spot right here, and 0.111 went down, and 0.074 amps went this way. Because you got to split the amps, because amps is flow. It's not a difference of potential. Questions?
Do you have another worksheet similar to that?
No, I do not.
No question.
Yeah.
On tomorrow's test, are we going to get something like this, or are we going to get something like that? Harder.
Okay. This.
Okay.
So let's talk about that other one. Yeah.
I was gonna say, can you finish the further totals?
Totals. Well, okay, so what should the total current flow be? If it's 185 here and 0.185 here, what's the total current flow?
185.
At 185. All right, and then we can do our total here, which we did on a previous page, but it is 50 x minus 1 plus 75 x minus 1, then x minus 1 plus 25 and 10. So you should get about 65, if David is correct. Because yours is the one right there. Yeah?
So you're adding 25, 15, 10K.
So if you were in lab and you gave me a circuit similar to this, of course yours would have 5, and I'm going to do it without grabbing another piece of paper, it's not too hard. I'm going to go 50 x minus 1 plus 75 x minus 1 equals x minus 1, and that's going to give me an answer of 30, that's right, 30. Then I'm just going to hit plus 25 plus 10 equals 65. And then I'll go 65. And then I'll do the math and I'll say, okay, because it's EIR. So I want I, so it's E 12 divided by 65 is going to be 0.185. All right, now I'm going to look at it. And I'm going to go, okay, then I know that 185 is here, 185 is there, 185 is here, and I can get that much done without even using a piece of paper and just looking at what you did. And if those line up, then this one's easy to get, that one's easy to get, and this ended up being what? So we use E equals I times R, so we end up 4.625, 4.625, and 1.85, 1.85. And I can look at that, and then I'll add this one and this one together, and it should equal 185. And if they do, then I know you're done. That's how I do it when I'm looking at your paper. So you want to know how to do this other one, huh? How much of this one do you want to know? Well, let's see. That damn thing, huh? Well, first of all, as I mentioned, all you really had to do is get R total. If you can get R total, you're done. You're good. If you're a glutton for punishment, try and work it back out the other way. I don't know if I can actually do this on this. I need that much room. But you can do that and say, all right, let's just kind of walk through it, see what we can do here. All right, so first thing is you got to start reducing, right? So I'm going to start all the way out on this end, on the far right-hand side. It's this side for me. And take a look at it. R2 is what? Is it in series? Is it in parallel? Is it parallel with what? With 3. So these two are in parallel. And so I've got 5 ohms and 25 ohms. So it's going to look like R2 and 3 is going to be how much? So it's 5x minus 1 plus 25x minus 1 equals x minus 1 equals how much? 4 point, we'll say 17 ohms. All right, and now that is now in series with R4, which is how much? 12. So the total of R234, R234 is how much?
16.17.
Okay, so 16.17 ohms. So we've taken R2 down to R34. We've got that basically right here. We said that's 16.7. It is in parallel with R5. So 16.17 x minus, see how it's starting to already get kind of sloppy and crazy.
Squarely.
Yeah, it's a little squirrely. So 16.17 x minus 1 plus 1000. It's 15.9. 15.9. So we're at 15.9 for our basically
15.9K.
1 through 5. What's that?
15.9.
15.9. No, it's 15.9 because it's in parallel, and I had parallel with 16.7, and if it's in parallel with something, then the resistance has to be less than the smallest resistor. So it's got to be below 16.7. Then we've got to add it to R7. So we got 15.9
Plus 8.
plus 8 equals, I have 23.9. So I have 23.9, all this becomes 23.9 in parallel with R6. So 23.9 x minus 1 plus 50 x minus 1 equals x minus 1 equals. I'm at 16.17, which is in series with,
R1.
so I
Add 10.
add 10 plus 10 equals 26.17.
Wow.
Ta-da. It's so simple. Now, going the other way is incredibly difficult. You can't do it the way I just did this because it's too sloppy. You have to be very, very careful. You have to label your, R2, 3, 4. You have to really be careful how you go back out. But that's all you had to do there. And then get the total current, which is 12 divided by 26.17 equals 0.459 is what you said? 0.459. Let me see. No, that's totally wrong. No, I'm just kidding. That's right. You wouldn't know. Yeah, it's right. No, that's right. Questions? Yeah, if you can do that, consider yourself done. You've got it. It's just a matter of identifying parallel series, parallel series, parallel series. Add them up. Keep track of it. What other questions you got? You ready for the test then? Yeah.
On the Q&A, the second quiz, the first question.
I have no idea.
I don't know. It's just, I've never seen it before.
Let me see if I can pull it up real quick.
You probably have to because
I have a picture of my phone.
you can read it to me.
I think the other one was like a complete circuit. It showed it was just like a box, and then it just had.
Oh, I think I
23
know.
Amps, and then 5 ohms, and this said what is
see.
the total
Second quiz, first question, right?
total wattage or something like that,
Oh, wait a minute. Let's do something different
or
here.
total power.
Oh, okay. Yeah, Kevin, so it was this one
Oh, I hate that one.
here. Right? Do you want to redraw it out real quick or?
Let me see if I can grab it real quick.
Alright, cool. Yeah, that one was real fun. Cool, the first time I saw it, I was like,
What's it going to be under? Basic electricity. Oh, it's 122 questions. What figure is that?
Figure 11.
That's what it should have done.
Yeah, figure 10 batteries are good.
Oh, figure 10? Let me see. Let's try this. There we go. What is the measured voltage of the series parallel circuit between terminals A and B? Dear Lord. All right. Yeah, this is a terrible one. All right. When you redraw it, it's like, duh. But you have to redraw it in a way, and it's not easy. So let me see if I can pull this one off. It's hard if I can't see both screens at once.
You want me? I can.
Yeah.
take my
What's
phone
that?
While you draw it.
All right. So, thanks.
Yeah.
I won't swipe left or right.
Oh,
Don't
thank
do
you.
it.
Thank you. There's things on there. You
Okay. So they've
A
got.
bunch of foot pictures.
I like the
Okay.
detail.
All right. So there are
Make that money, man.
4 batteries. All right, and so we can just do a single cell battery.
So those circles are batteries?
Yes, they're batteries.
Got it.
And we're going to go back here so you guys can see what I'm looking at. So these are just batteries. And maybe I could do it right here. That would be fine. See.
Is that just an alternate way of drawing the battery, or is there any significant difference? I mean,
It's just a way to screw with your head.
Oh man.
Mission accomplished.
This is one of those questions where they would probably advise you to just memorize it, but you don't have to. I mean, there's a lot to memorize if you do that. So I'm kind of working on my instrument rating, and by kind of it means because I'm dragging my feet like you wouldn't believe, just because I'm busy. But so I've gone through all the prepware stuff, just like you guys do. And then Phil said, "Oh, you should use Shepherd Air." Okay, Shepherd Air is fantastic. $45. I mean, it's the best quiz prep you're ever going to get. They don't have it for mechanics. I thought, oh, this would be awesome, but they don't. And so much of it is like, well, your best bet's just to memorize this. I'm like, well, no, your best bet's to learn it. So, all right, so I remember having to try and learn this one. And so I just redrew it. Okay, so the thing I want to figure out is what is negative, what is positive. So the outside of this is going to be negative, and this is the positive. All right, so that's positive. So we're just going to identify that. Everybody follow me so far?
Yeah.
And the way I got that is I just went negative here, touches the outside. The positive wire touches the inside. So, all right, so then I redrew it. All right, redrew it. And this one goes positive to negative, positive to negative. This one goes positive to positive. This one goes positive to negative. And this one goes from the negative down to the negative post, and this goes.
Sorry, go ahead. The last second to the last one you did, top right?
This one.
Yes.
Go ahead.
Negative to a positive?
This goes positive to positive.
Okay. And then,
Okay. Here's where it gets. So that's
Oh,
easy
okay.
so far, but this one goes negative here, and then it goes to right there. That's what's going to make it a little bit difficult. So, huh?
positive B terminal.
Yeah, we need the positive terminal. Positive terminal's right here. Right? Okay. So, can we redraw that to look at just a little bit different? Just slightly different. I'll tell you, I'll just do blue where I'm going to make the changes. I'm going to take this line and move it to right here. Electrically the same thing, right? I just moved it over a little bit. Now I'm going to erase this line right here. I'm going to electrically, it is right here. Yes?
mm-hmm.
All right, so now we can get rid of some of the stuff we don't need. We don't need that. I forgot it works this way. Don't need that. All right. I barely changed it, but I changed it just a little bit. What do you see?
Series.
Series and parallel.
It's a series parallel. So we'll call this battery 1, 2, 3, and 4. Batteries 1 is in what relation to number 2? Series. Battery 3 is in what relationship to 4?
Series.
Okay. Probably, well, when we talk about batteries, I would have covered this. Really, maybe I should have covered it in this lecture here, but it's something to know. When you have batteries in series, so now we're working over here. So let's just say I have we'll do a battery here, multi-cell battery, and we'll say this is 4 volts, and I do it like this. Let's ground out. All right, and I put my voltmeter across there, and there's 4 volts here. So I put the voltmeter right here. How many volts do I get? Why 8?
Because they're in series.
Because they're in series. Well, what if I did this? Four volts, 4 volts.
You only have 4 volts.
Are they in series or parallel?
Parallel.
Parallel. Okay, so let's go back up to here. We have series. In a series circuit, resistors, what do you do with the voltages? You add them up. Series circuit with batteries, you add them up. So that's going to be 8 volts. Here we have parallel. So in parallel, you do what with resistors? The voltage drop on resistors, you stays the same. So therefore, this would be parallel 8 volts. 4 volts is exactly correct. Yes, 4 volts.
Is your possible output amperage double?
Is there what?
Is the possible output amperage double?
All right, that's where I was going when I wrote 8. I was thinking ahead to how am I going to say this next thing. All right, so let's say this battery, each battery had a potential of, let's say, 2 amps. 2 amps. Well, I have now 8 volts. What is my potential amperage over here? 2 amps. Just like resistors. So this one has 2 amps and this one has 2 amps. What is my potential amperage here? 4 amps. So that's exactly, well, we're going to look at batteries, and that's exactly what we're doing with batteries.
How did you get the 2 amps again?
I just wrote it down. I mean, how did I get 2 amps total?
Yes.
Or 2 amps? Okay. When you're dealing with resistors in a series circuit, and I said this resistor has 4 volts drop, and this resistor's had 4 volt drop, what is the total voltage drop? 8. And what do you do with the amperage? Does it add, subtract, stay the same?
I don't remember.
Oh, there's a problem. Series circuit. Series circuit amperage. Kirchhoff's law.
Oh, okay. Right.
Right?
Got it.
Go back to something like this. Here, simple series circuit. Have 1.85 volts, amps. How many amps do you have here?
Oh, so you just chose 2 and then...
I just chose to. So I just wrote it
okay,
down.
There you go. Okay.
All right. All right. So same thing is true. The amps stay the same. The voltage is going to increase by each battery. Go back to a parallel circuit. Your amperage stays the same.
Right.
I'm sorry. Your amperage adds up. Amperage adds up. So 2 plus 2 is 4. 2 plus 2 equals 4. But your voltage stays the same.
Same as resistors.
All right, so we take that one step further. You've got 2 car batteries. Here we go. And each one is 12 volts. And each one has a potential of, let me think. Well, we'll do more with batteries. We'll say 400 amp hours. It's 400 amp hours, which means you can get 400 amps out of the battery in an hour. Follow? All right, this is not going to be on your test this week. And so this will be the positive, negative, positive, negative. That's going the wrong way there, Kevo. My dog calls me Kev. It's a joke in our family that the dog calls me Kev. Okay. So here's my positive. It goes positive here. And I go, let's see, we'll do this one. Negative, got the negative. Oh, in red, nice job. All right, that goes to there, and that goes to here, and that's negative. Are they in series or parallel?
In series.
In series. So how many volts do I have?
Like 24 volts.
That'd be a 24 volt battery. How many amp hours would I get out of it?
400.
400 amp hours. 400 amp hours, because the amps stay the same. But I'm going to get more pressure out of it. All right? So now let's reconfigure it. And can I just use blue and reconfigure it? So this can be my positive, and then this goes over to here, and then negative, if I did that right. And then this one goes positive to there. That looks terrible, but what I did was a parallel, put them in parallel. Let's just do this. You can actually see it, so it doesn't look like a scribbled mess. Battery. Ooh, I know. Battery. Positive, negative, positive, negative, positive, negative. 12 volt battery, 12 volt battery. Each one has 400 amp hours. What do I end up with? 12 volts, because they're in parallel. And what happens to the amperage?
800 amps.
You add it up. So now we get 800 amp hours. All right, back to where we started.
It's like jump starting a car.
Yeah. All right, so we're back to here. So 1 and 2 are each 1.5 volts, and they are in series. So what am I doing with the voltage? Add it up. So that's how many? 3 volts. 3 and 4 are in series. Therefore, it is 3 volts. 3 volts and 3 volts are in parallel. Therefore, you keep the voltage. So it is 3 volts. Was that the right answer? God,
Yeah.
that's the right answer.
The answer is 400 amp hours.
Yeah. Wait, where's the 400 amp hours come in? You lost me there. Where's that website? There we are. Two batteries on the left side are connected in series, and the two batteries on the right are connected in series. The two pairs of batteries connect in parallel. The series connection between A and B give the circuit 3 volts. Yeah, no, the explanation's true, but it's got to draw it in a way that makes sense. What else you got?
It's like a little circuit. It has the light, says 23 amps, and then 5 ohms, and then it says what's the total wattage.
Hang on.
Yeah.
I'm following you.
You done on my phone?
Oh, yeah, your mom called, by the way.
Did she?
Damn it, son.
We'll call her back.
She said you wet your bed again. You need to go home and change your sheets.
Shit, she's in the East Coast. How'd she know?
What show was that on? That was show us.
Paper time.
Having technical difficulties here. Let's see, turn the page. Oh, that didn't help at all. All right, get back to that.
Yeah.
Okay, tell me again about. think it's figure 7. No, it's that one. Figure 4. Okay. That one. How much?
Well, that would make sense, that it has the ohms. In the other picture, it doesn't have the ohms.
Say what?
I think it does.
It just says 5. So,
But I think,
Oh.
I think it says there's 5.
5 gallons, right?
I was like, 5 what? Like, what am I looking at?
Gallons. Yeah. All right, now you got it.
So I think so. It's
Kevin, sorry.
So, yeah.
What is that squiggly line? Thank you.
AC generator. It's AC.
yeah, totally.
This is an ammeter.
Yeah.
So, all right, you should be able to work that one then.
So it's
All right. Anything else? Yeah.
Could you do a series parallel circuit with 5 resistors? Like the example that you had up there with the 4, but
Do it 5?
we'll do 5.
Yeah. All right.
Yeah. With
Yeah, you're gonna have to tell me to design it. So hang on.
the example that you had that we worked through from the worksheet yesterday.
Yeah. Yeah, but you want 5 of them. So you want.
So
wha-
just like in series with the resistor.
Oh, okay. He's a mad dog over there. All right, so he wants it like this. Like this. Then like this. Oops, there's one more here. Then like this. Then over. Right?
Yep.
Okay. Give me some values. How many volts?
10.
Ohms.
10.
You can say 10 for everything?
100.
R2, 100.
1.0.
This is going to be R3. Ohms,
25.
25.
1,000.
And R4, 1,000. R5,
50 meg.
no. Huh? 50, because I already got half the fiber. Okay, 50 ohms. Okay. So we're going to have to, we start at the right side, the furthest from the battery, and then start working our way in. So R4 is in what with something else? It's the first thing I'll look at. Sure, it's in parallel with R2, but what's standing between?
R3.
Series with R3, right? So redraw. All right. Hopefully I'm not getting too small here. So this is
R3 or 4.
R3, 4 is right there. And R3, 4 is 1025 ohms. And that is in parallel with R2, which is 100. So we're going to end up with this and this. But that one right there is R2, 3, 4. So we have 1025 in parallel with 100. So R234 is
91.11.
91.11 ohms, which is in series with,
R1 and R5. So
R-
add 60
add 60, okay, plus 60,
is 151.11.
151.11 ohms. All right. 151.11 ohms. So what is my total current?
Zero six six.
Say again.
0.66.
How much?
0.06.
Point zero.
66.17.
Oh, wait, no.
Point, all right, I gotta do it myself now. See, because it's EIR, where I is equal to E10 divided by 151.11 equals
66.118 million.
and I just hit the wrong button twice, divided by 151.11 equals, you said? Point,
66.18 million.
all right, so we're just going to go 0.066. All right, so right here, this is EIR. We know it's 10. We know it's 0.066. This one right here, we know it's 50. We know that it's 50.066. And we just have to figure out the voltage drop here and here. All right, so that was pretty easy, right? All right, but we got to go down to this one here and solve for all this. We got 0.066, 10 ohms, 0.066, 10 ohms. And what is the voltage drop here?
No, I thought the bottom resistor there was 50 ohms.
50, sorry, 50. Right here we have
0.66 volts.
0.66 volts. Right here we have
3.3 volts.
3.3 volts. And that means that over here, R234, where we have 151, we still have 0.066 amps, and the total voltage drop across all of them is
9.97 volts.
everybody following so far? Is it too sloppy? Did I kind of, because I can redo this and do it on the board really big, and it might make more sense, but as long as everybody's following. Okay, so we've solved down here, and now we know what, that's it. That's the answer for 1 and 5. That is the answer. It doesn't change. We figured it out because this is R1, this is R5. It is what it is. Now we just got to figure out this whole mess here, R2, 3, 4. Well, so we go back up. Feeding into, then, this right here, it's like we are saying this. This is my total right here. And so, what is the voltage drop across them? 9.97. 9.97. This is R2 right here, by the way. So R2 happens to be 100 ohms. We know that. And so what is the current through R2?
Was it 0.0997?
Anybody disagree? Okay.
Just my head.
And right over here, what are we dealing with? R34, right? R34, that's what that is. Right here, we said R34 is 1025 ohms from a while ago. So,
Should the voltage be like about 6 volts instead of almost 10? Total's 10 volts.
yeah, who told me that now? Yeah.
What's the
Maybe got, yeah, it's got to be about 4 shy there. So hang on, let's back up here.
So instead of 151 ohms in the red box, it should be 91.1.
Somebody lied to me. All right, so we do have,
It's 91 ohms instead of 151.
oh yeah, right here, 91. That's the problem.
Okay.
It wasn't total, it was 91. Everybody with me? So I told you the secret is to keep it neat. 234, it's 91 ohms. It is 0.066 amps because it's still 0.066, 0.066, 0.066. And that made the voltage drop
6.01.
6.01. All right, so if that's 6.01, feeds into this, looks like that. We've got it's our total, so that would be 6.01 volts. Therefore, the current flow here is
.06.
How much? Points. Point.
0.06,
There's got to be a point in there somewhere.
I said
Yeah.
point
Point
zero six.
0.060.
All right, and then over here we've got
Is .006.
that'll work.
Point 0058.
That will go 0.006 amps. Amps, all right. And let's see, those two add up just fine to that, so that works. So here's R2. There's the answer for R2 right there. We did it, R2. That is the answer for right there. So now we've got this left. We've got R3 and R4. All right, so R3 and R4. Here's my total for R3, R4, right there. So it's like we did this. Right? 3, 4.
Mm-hmm.
And this total just moves up to right here. So the total current flow is 0.006. So if we did EIR and EIR here, a little bit. We know the resistance right here is 25 because it says 25 right there. We know this is 1,000 because it's 1,000 right there. And we know that the current flow is 0.006 from right here. And if it's 6 here, it's 6 here, it's 0.006 there. Therefore, the voltage drop here is going to be
No, 0.15.
0.15, and the voltage drop here is
Yeah, 6.
okay. So 6 plus 1.5 equals about that. Got off a little bit somewhere because we rounded to 6. It was 5.8 actually, but that's fine. So there we go. There's the answer right here for R3. And here's the answer right there for R4.
That was a fun one.
All right, break time.